Hello everyone, welcome to our talk on Yara Rules on Steroid, where myself, Saurabh Chaudhary, and my friend here, Laksh Dubey, are going to talk about advanced utilization of Yara Rules and how can we make better rules for advanced and long-term detections. My name is Saurabh Chaudhary and I'm a cyber threat researcher. I have experience and expertise with threat intel, malwares, and reverse engineering. I have experience working in the banking and financial domain. I have spoken and trained people at multiple international conferences and training. You can find me on Twitter with the handle 4W4R44, and if you find any interesting malware samples, please do hit me up on Twitter. So here I'm going to talk about what is Yara, how can we make it, what is string based and code based rule. I'll show you what's better and why, and then my friend Laksh here will take you towards a deeper dive into Yara, where he will show you a demo on creating Yara rules from a live malware sample, and he will also talk about automatic Yara creation and life cycle of Yara rules and other important facts around it.
So these days, malware comes in a lot of forms. So we see a lot of sophistication and complexity in malwares. These days, malwares are becoming complex, invisible, tricky, and sophisticated day by day. So how can we track them down? They comes in different forms. So how can we track them down? Your answer would be Yara. So with Yara rules, you can understand and scan these different types of files up to the byte level. So Yara is your answer. Now what is Yara? So Yara is a tool which is aimed at helping malware researchers to identify and classify malware samples. With Yara, you can create descriptions of malware families or whatever you want to describe based on the textual or binary pattern. Each descriptions, or you can call it each rule, consists of a set of strings and a boolean expressions and a conditions which determine its logic. Yara was created by Mr. Victor M. Alvarez, who works for Virus Tutor. So it's a open source product. It's an open source project, and you can go on GitHub and start using it. So with Yara, you can identify and classify like almost anything, and from anything I mean like you can put up a string based search or paste bin or scan for anything else. So what can we do with Yara? So Yara comes with immense power and capabilities. You can identify and classify files and malwares. You can find new malware samples with the help of Yara. You can track some APT groups with Yara. You can even scan the network. You can scan the memory file. You can scan data streams. You can even filter network traffics. You can help speeding up incident response. You can build your own anti-malware product. Yara was being helpful to catch big APT groups like equations, Turla groups, flames, etc. Now let me show you how Yara rule looks like. So this is what a Yara rule looks like. So the Yara users are like rules, name of the rules, the file name, and the directory to be scanned or the file to be scanned, or you can scan it against process ID as well. So here I'm scanning it against Yara, the name of the Yara rule, and the directory which I am scanning it against, and we got 2 matches up here. I'll show you in case you have never seen a Yara rule. This is what a Yara rule looks like. So this rule, the rule identifier, the name of the rule, which is in case besides Budapest underscore. The metadata is necessary so that wherever your rule goes, everyone would be knowing that what this rule is made for, and it will keep a track of things. And the strings, so I'm searching it against these 3 strings: besides, online, and Budapest. And the condition is if all of the strings, this $sign is a string identifier up here, you can see, and Yara rules are case sensitive. So using this no case, it will assure that if it is in lowercase or uppercase, it will give us a match, and the condition is all of these strings should meet. So let me show you. So this is our rule. So this rule will be detecting for these 3 strings. Now let's run this rule. The condition is if any of these 3 strings meet. It's not necessary that all of these 3 strings should meet. We can also write them as all of stars. That would also work. Let's run this string. Let's run this Yara rule. So Yara, and name of the rule, and the directory to be scanned. Here in this case, I'm scanning here in Yara and presentations. So I have scanned this presentation directory, so this has been scanned everywhere, right? Let's see what have we got. Even with using -r, we can recursively scan that as well. So scanning this has given this is the name of the rule, and it has found a file which has matched against your rule. It's a txt file. Let's see what do we have. Cool. So we have these 3 strings in this txt file. That's why it matched. So that was a small example that how it works on strings. We will talk about it in further slides. Coming back to the slides. So generally Yara rules are made up of string, bytes, and regex and metadata, which is used to keep track on things. So you can the rule understands it like as a comment. But most of the rule which you will find out there, they are based on strings. And regex is really not recommended because it provides a lot of false positive. Regex, regular expression, produce a lot of false positives, so it's not considered good. So always go for a mixture of byte and string. So each rule in Yara starts with the keyword rule followed by a rule identifier. Like in our case, This is the rule identifier. Identifier must follow the same logical conventions of the C programming language. After that comes the metadata string and the conditions. So this is the metadata, strings, and the condition. So we can use it as a condition, like what I showed you. We can write is these identifiers, any of the stars, or we can if we are searching it for an executable entry, we can provide the magic header of the executable depending on if it is a PE or it is an ELF. It varies. We can even give the file size, like search for any of these strings and the file size is less than this much of KBs or whatever, or we can write it any of the strings or all of these or entry points. There are a lot of things, lot of identifiers. So rule, the rule name, metadata, strings, and the condition. So why code-based Yara rules, and why we would be talking about code-based Yara rules? And before that, let me tell you that the string definition section can be omitted if the rule doesn't rely on the string. It's one important thing. And each string has an identifier consisting of a dollar character, which you can see here. Strings can be defined in text or hexadecimal form, and the conditions section is always required. This is necessary. So conditions are nothing more than a Boolean expressions as those that can be found in all programming languages. So the condition based on the rule set tells the rule that what to do. Now, why are we talking about code-based Yara rules? So rules should be written in such a way that it is not only limited to detect only a specific sample. Rules that match to only a specific sample are not much better than a hash value. So code-based Yara rules. Why code-based Yara rules? So code-based Yara rules last for generations of the malwares. At least a few generations of malware, and you can track the different malwares from the same malware creators if they have used the code from the last malwares during the development, which generally they do. They all work as a software development company as well, where they use the functions and a lot of their codes as well. So I'll show you in a demo that why these code-based rules are everlasting, at least. So let's praise to the demo god that everything works fine. So here I have two C++ rules, C++ programs. I'll show you both of them. So one, both of them prints hello, right? So if you comes from C++ background, you must be knowing what I'm talking about. Otherwise, I'll give you a nice explanation of this. So what it is doing is they are printing just hello. In the first program, in the sample 1, they are just printing hello as a string, and in the second program here on the right, you can see I'm storing the value of HELLO in differently. I'm storing those values differently, and then I am adding those values to print the same thing. These two programs will generally do the same thing. They will print hello and nothing else. Now let me compile these two programs. So I'll be using GCC compiler, the name of the sample 1 and -o, and I'm gonna name it sample 1 only. Okay, sorry, I have to add the extension as well. So, and I'm gonna name it sample 1. Cool. You can be, if I'll press enter, you can see the file compiled and coming up here. You can see that, right? Let's see what this does. Sample 1, it only prints hello. Cool. We will do the same with sample 2 as well. We are going to compile them, sample2.cpp, and we are going to name them sample 2. Cool. You can see this has been created just now. So let me show you what this sample does as well. This also prints hello, as you can see here. Cool. So both of these programs prints only a string, right? So for example, you can take, if it is a malware and a CNC IP or a CNC domain has been coded in the malware like a string, so it can be like there are a number of possibilities, but I'm showing you just 2 possibilities, and I'll make a nice Yara rule to run against this. Cheer. Okay, so I'm gonna write a nice rule. So the rule starts from the rule, writing a rule, and the name of the rule, which I'm gonna name is as hello, then braces, then meta data, I'm gonna write author, I'm gonna write description, searches for hello, and I'm gonna write strings with the dollar identifier, which is here. And we have to make it like this, hello, and so that it is not case sensitive, I'll write no case, and a condition. So the condition is string. should match the string, right? And I'm gonna save this. So our Yara rule is ready here. Hello dot Yara. Nice. So let's see if it is working or not. Yara hello dot Yara and home. But first let me make a new folder named executable, and I'm gonna place these executables up here and this one as well. So for your understanding, let me show you, these are ELF based executables. You can see the file is 64-bit ELF file. The same goes with sample2 as well. So I'm going to test my Yara. Yara hello dot Yara, and I'm gonna scan the whole executable directory with that. It's in desktop, and a lot of directories I have made. So what this is going to do is this is gonna I think there's some problem with the Yara. Let me see. Okay. Okay. So this is the problem. Now it should work well. Looks like string here will go like this, and the description author will go here, and this will go here. Okay, cool. So now this is running. The problem was with I was using a colon instead of equals to. So what happens here is let me show you. So I have searched this Yara rule hello.yara against this directory, the sample and executable, and this directory contains two files, right? This directory contains 2 files. Let me show you. Presentations, samples, executables, right? So it will give you only, it flags only one file against this rule, but both of these files are printing hello, right? In the executable, let's go to executable and let's let's see what this file does. Sample1, it prints hello, and the same goes with sample2. Both of them prints hello, but only one file is flagged. Now I have written a code based Yara rule. Here you can see that. So here we are not using strings, we are using bytes. So bytes, these bytes are based on the functions which this program is using, and this ELF is the magic header of the ELF file, which differs for if it is a window, if it is a Linux based binary, or if it is a Windows based binary, if it is a PE file or if it is an ELF file. And if it suffices both of them, then it's going to flag. Now let's run this rule against our sample. Yara, let me do it like this. Should be good to view. Expand this. Hello byte.yara. If you will directly click it, it's going to show that wrong number of arguments. You can do a lot of things with Yara. Let me show you. These are the options you can combine Yara with. You can use recursive scans. You can use fast scans with -f. You can use a lot of things. You can increase the number of threads and everything. So let's see about our rule. And we are going to scan it against this directory. Let me scan it against the whole Yara directory. Okay, so this only scans in the Yara. If I'll add a recursive, then it will scan into the inside of these subfolders as well. See, I have recursively scanned, so if it is anything inside the Yara folder directory, a lot of things, so this rule has triggered. That's how it shows. This rule has triggered, and which file it has triggered for is sample1 and sample2. So now you have seen why it is necessary that we use a code based Yara rule. Coming back to the slides.
Now my friend Laksh will take you towards demo and some other practical implementations. Handing over to Laksh.
So thank you, Saurabh. Let's begin. My name is Laksh and I am from India. I work for Volon as a threat researcher. Apart from this, I have keen interest in digital forensic, darknet monitoring and malware analysis. Over there is my Twitter handle. If you have any queries regarding all these technologies, feel free to reach me. So thank you, Saurabh, and now we will look into malwares and try to create our signatures using malicious binaries. So over here I have few malware samples, and now we will look into them and try to create our Yara rules using it. So let's start. And so over here we have 6 malicious and non-malicious binaries we don't know. So we will try to create our signatures and identify like out of the 6 how many binaries are malicious. So let's begin. So first thing first, I will suggest is the best practice is to use all the 5 encodings. So they give positive results, and now we will see in few minutes like the kind of results which we are talking about. So let's start and try to extract strings. So we will start with the 7-bit encoding, which is FNS. And okay, so let's look for strings. So over here we will find various DLLs, and this seems to be legitimate, but just below few lines we found another DLL which seems like it is not normally seen in Windows environment, so like it can be suspicious, so we will include it. But let's first begin our rules. So rule and crash. So this will be the name of a rule, and let's begin with the structure. Okay, so first we will add meta, and over here we will put some metadata like date, okay, so the string should be in the double inverted comma. So this is the thing which we have to remember. If it is in single or anything else, like the rule will reflect an error. Okay, so apart from this we can add various other details like the name of an author, MD5, and various other things. So like for now we will just add this 2, and now let's begin with strings. Okay, so the strings has to be in dollar, the name of a string, and then the string will be in double inverted comma. So like we will add our launcher.dll in this. Okay, so it's over here. Okay, the next string is 2. Okay, so let's move forward, and the thing is we have to look into all these strings, so we have to go through the whole string. So over here we get few API calls, and we will not include the API calls because if we add them, and because this calls possibly can present in the legitimate binaries as well, so if we add them the rule will give various false positives, so we have to ignore and look for very unique strings which are less chances which will be present in the common binaries or the non-malicious binaries. So we have to go through all the strings, like we can see these are just random values, so it will not be good if we add them in our signature. Okay, so this is also a legitimate binary. Okay, again few API calls. So this is what we have to do in creating a Yara rule. We have to look into strings again and again. So till now we just found one. Okay. Okay, so then again these are some common names, so we will exclude them and look for something else. Okay, so over here we got few. Okay, so this is some sort of directory path. Okay, because this is possibly a name of a folder, but it just below it this is something different, so we will not include it. Okay, so in Yara we have to use double slash. Okay, so again next string. Again this is something different which is not commonly present, so we will include this binary as well, like the name. Okay, again, and over here we found one URL which is a random one, so we have to add it as well. So the more strings you get, the more efficient rule you will have. So we have to look for few more strings. Okay, over here we found a name of a mutex, so yeah, we will add it as well, and just below it a same name which we found previously, so we will exclude it. Okay, okay, again we can add this as well. And this one too. Okay, so I guess let's move. After this we will move into some different encoding as well, so we can find few other strings too. Okay, I guess enough. We can now look into some different encoding as well. So let's move into 8-bit encoding now. Okay, so for 8-bit encoding it says, and I guess this is okay, these are some random characters. Okay, we can move forward, and now we will look into 16-bit one. Okay, okay, so see over here we got an IP address. This can be a IP of C2 server or something else. So this is the reason I told previously, like we have to look for strings with different encodings. So okay, now one more for okay, so another IP address as well. So okay, so let's add this one to the encryptor. Okay, so I guess 10 strings are enough. Let's add a condition as well. So condition can be in various form, but for generalized way, for now we will just add 3 of them. So what this rule will be doing is, if okay, let's just okay. So what this condition will do, if this rule finds any of any single string in any these 6 binaries, it will trigger. Okay, so just let's save it and try to test this rule. Okay, so every Yara rule have to be saved as name, and so for now we will give it then dot yar or complete name of Yara. Okay, so both will work fine, but we have to give it a syntax. Okay, so keep this in mind. So our rule is here. Now just let's see what it does. Let me put this dot. Okay, so to execute a Yara rule, first we give a Yara and then the path of a rule. So our rule resides in WannaCry, and this is our name of a this is the name of a rule, and now we have to give a directory which we want to scan. Okay, so just to be clear, the Yara and the path of a rule, this is the path of a rule and the directory which we want to scan. Okay, so our rule work fine, and possibly 1 2 3 4 5 6. Okay, so this is our Yara rule. So all the strings are present, so that was the reason it was triggered. Apart from this 6 are the binaries. Yeah, they are all binaries, so all the binaries belongs to WannaCry ransomware family. Okay, so this was for WannaCry. Let's move into some, this was basically a string based rule, so now let's look up code based rule. So over here we have 4 binaries, and now we will look for out of this 4 which is the malicious one, or which belongs to a specific malware family, something similar things which we will be looking. So for this we will be creating a code based rule. So let's move into our another virtual machine. So over here what I have done is I have opened 2 malware. I will just name for you. So these are the 2 binaries which are opened in a disassembler, and see over here I have just opened the place which we will be working on. So see this section of the code, and this section of the code, we found few common strings. Like look over here, like 89F2, 89EA, C1, EA0B. So things are quite similar over here. So what we will be trying is, we will try to create our rule, and just a second, I will open my notepad. Okay, I have to work over here only. Just a second, I will open my notepad. It's accessories. Okay, yeah, I got it. So what we will be doing is, we will try to note down few strings. So while creating a rule, we can wildcard the things as well. So to wildcard, we will just use question mark. Okay, so let's begin. We will start with 89. Again, see, we have to wildcard two characters over here, F and 2 and E and A in the third next window. So we will wildcard with 2 question mark. Again, C1 is common, so we will keep it as it is, and EA. This is okay. So what we will be doing over here is, like, this register values can be changed. Okay, so we can wildcard it as well, or we can keep it as same. So for now, like, we will keep it same. And again, 0B. Okay, so like, this is the fixed value, so we can keep it same as well. So 0B. So what we are looking is, we are working on this opcode fields. Okay, so next is 0F, AF, and again, see, the things are changed over here. So D1 and D7. Okay, so like, we can do this way as well, or we can wildcard it completely. So both will work fine. So for now, we will just wildcard it completely, because in this cases, what happens basically is, as the compiler gets changed, or the register value get changed. So this sorry, not register value, the register get changed. So this values opcode will also get changed. So this is the reason why we are trying to wildcard it and get some effective strings out of it. And the next one is 39. Okay, 39, and again question mark 72. Okay, so like, we got few values, and the rest of the code is different. So like, okay, we can work with this. Let's see if it gets copied. Okay, so what we will do is, we will create another rule. Just exit it. I will create another file. Okay, let me see. Okay, it worked for us. Okay, so again, rule ts will be the name of a rule, and again, the code structure. Okay, meta let's move into this strings. Okay, so in this case we have completely different strings, like it's a hexadecimal value. So for hexadecimal values we will be using curly braces, not the inverted commas, okay, and like double inverted commas. Okay, so again condition, and in this case we have one single string, so we will just name it, and I guess it is fine. Okay, so let's save it and test how it works. We have to save it over here. Yara. Okay, so let me open. Okay, this will look fine. Again Yara tx.yara, and the directory which we want to see in it is okay. So let's see. Okay, so it triggers for 3 binaries, and the rule has excluded this 4th one. So what might be the reason is like this is the unique hexadecimal value which was found, which is present in this 3 binaries. So similarly we can create rules for all kind of binaries, malicious, non-malicious, and we can even create these rules for exploit and other tools like this. I have a pre-created tool, Yara-Rule for mimikatz. So like this were the strings which were found. So we can use in both ways, like the text base and the code base. Okay, so the rule works fine. So again, this is the way to like wildcard things in Yara, like any value over here which is present, which is ranged in between 0 to 3, it will trigger that. Like if it is 2, it will work. If it is 1, it will work. If it is 0 or 3, it will work for them as well. Okay, so this is what a rule for mimikatz look like. Okay, so let's move further. So this is the reason why we focus on code based rule, or you can also include a code based rule with few strings. Okay, so like this is your call in what direction you want to move, but we will suggest you focus on code based rule because they are more effective in hunting and detecting malicious binaries. So by code based rule, this is the main part we want to focus on. So they are mostly effective and they last long because the malware authors don't usually modify their entire code. They try to use few portions like which we saw previously. So they reuse few portions of the code from other binaries or other malware, so it become easy to detect them using a code based rule, and one single rule work for all multiple binaries. And we can even track various malwares and malware families using this rule, but this is not possible for a string base because strings can be changed, and other protection mechanism makes it difficult for identifying these strings. So things to care while creating a code based rule. Okay, so compilation flags, different compilers work differently and they change their instruction set, and like register value get different if we change different compilers. So this will generate different opcodes, and don't use wildcard in vast amount, because it will generate errors, or not exactly errors, it will create a load on a machine and your machine will get hanged or freezed. So this is the reason we don't use large amount of wildcard. Use them effectively, that's what we suggest. So testing Yara rules. So what I will suggest is create a big amount of sample lab and laboratory. So like, just let me show you. I have one with me. Okay, so like over here I have created a big, around few samples. Okay, so you can just create a more big amount of collection and just use them to test your rules. So this will give you good understanding of like how to create an effective rule which reduces false positive as well. Okay, so we have to test the rule on malicious and non-malicious binaries as well. So keep this in mind to create a big repository of both kind of binaries, and then test your rule for effectiveness. And this is a good project from Kaspersky, like the Clara project, and this helps to test this kind of signatures, and it is quite effective. It just scan large amount of file in just very less time. So we will suggest you definitely visit this and test this project over your system. So the life cycle of creating a rule. So first start the analysis of a malicious binary, and then you have to look for eye-catching strings, like identify unique strings which cannot be present in the general binary, which is Windows binary. Okay, so like try to detect few IP addresses and file names or name of a mutex, so kind like which we saw previously. Okay, so we have to detect unique strings, and then we have to create a rule that thoroughly test it on the clean and malicious binaries. Then you can just deploy it in your production and monitor for further changes or upgrades. Okay, so keep one thing in mind, like you have to test your rule, because testing gives you the idea, like we have to what kind of false positive which you can reduce, or whitelisting and similar things. Okay, so like test your rules on clean and malicious binaries. So you can also check your rule on various online platforms like hybrid analysis, malpedia and virus total. They support, like you can just upload your rule and just compile it over there, and then it will work and show you the results. So there are another way, like you can use automated tools and scripts to create your Yara rule. Yara Gen is quite effective when it comes directly from Florian Roth, who have worked a lot in this Yara field. Okay, and apart from that, MK Yara is also quite a good project. You can just use this 3 according to your requirement and create automated signatures. So where can you use this, or what can you do with this Yara rules? Okay, so like you can find vast amount of malwares which are actively present in the environment. You can hunt for APTs, or advanced persistent rate, 0 days, and they are quite good in monitoring as well. Like you can not only monitor binaries, you can also monitor network traffic, and you can look for malicious activities in those network traffics. And apart from that, you can also make your own antivirus. So like it's quite a good thing. You can just work according to your requirement. You can also work effective in the forensic and incident response. Like you can just detect, you just consider a scenario like you got a memory image and you have to identify malicious process. Like you can create a set of your Yara rules and just test, run it over that memory image, and like you will get a trigger or some sort of alert, like if it is a malicious or not. Okay, so this comes very handy. Like Yara has come very handy in this kind of scenarios. So just to conclude, like code based rule needs the good understanding of debuggers and disassemblers. Like you have to go through opcode fields and try to understand the code. So like in this situation you need a good understanding of debugger and disassembler, and strings might not be there. Okay, so like as seen, like strings are not those that effective as compared to code based rules, and strings can be changed, or obfuscated code can become will give different kind of strings. So like this comes here comes the code based rule. So you have to go through the code, understand the code, use debuggers and disassemblers to understand it, and identify unique part or the reused part and use them in your code. Okay, and the code based rule will last long. Again, I am telling you that. So it will give you long hits. Like you can detect various malware families and detect vast amount of malwares which belongs to similar families. So that's what that's end. Like thank you. And another few just reference from our side, like you can use these things to kickstart your development of Yara rules. Thank you so much, and it would be thankful like if you get any questions and feedback from your side. Thank you so much.